Welcome back, everyone. And today is going to be a special day. If you're here to learn something new, like some new programming, you can leave now because this video is mostly about fungi. I spent the last 2 weeks rebuilding fungi from the ground up. So if you're interested, if you're following the series mainly to how fungi is being built, how all the little bits and pieces that we've past year spent building up the framework, stick around. But if you're here just learning new WebGL or game development type of things, save yourself the time and wait for the next video. So now that we're here and we are really going to talk about fungi, why did I rebuild fungi yet again? I rebuilt fungi mainly because it's gotten really messy in the past year. We went through a lot of refactoring, and we started off with one way of doing it, then we went to a different way, and now we're using everything rewritten to use ES6 modules. So everything got really messy and complicated, and so I just wanted to clean it up. I got laid off like 2 or 3 weeks ago, so I had all the time in the world to really just sit down and really redesign fungi in a more logical and reasonable way. Everything we've done for the past year is still there. It's just things have been moved around, things have been improved. Certain things in hindsight weren't the best ways, so things were changed. So I'm just going to really kind of just highlight and maybe show some code for those who are actually interested in how the framework is being built. Yeah. So one of the main core things that I changed is transformation. If you remember when we were building fungi, we made transform. It's kind of the root object. It's the game object or the entity object that other game engines might use as the starting point of how they build objects on the screen. Originally, I had we had like a mechanism in there, so we would check to see if the data was updated, and if data was updated, we would then recalculate the local, world, and normal matrix. So that's a lot of so if we didn't need to update those matrices, we had a mechanism to make sure we didn't, not waste CPU time doing all that extra math. Because if there's a lot of things that are static, there's no point in redoing all that math every time we render a screen. Problem is that made the math library dependent and not vanilla, not pure. So I wanted the math library to be clean. So that means because there was the vector3, the mat4, the quintorian, all that actually had is a modified attribute, and then every time you ran a function to it, it would actually update that status. So the status is now built into transform itself. So transform itself now checks to see if it's modified, and as you can see, I have put underscore. Now I underscore things now to denote that these things are private and should not be modified outside of this class. JavaScript doesn't allow us to do private properties, so I just make a note that these are privates. These should not be modified. If you modify these outside this object, you will then cause problems for yourself. So you don't do that anymore. So to fix that issue, I created new functions that allows us to kind of modify it. So if I want to get the data, I have functions that let us get data. If we want to add to the position, set the position, get the position. So we have a lot of getters and setters to make it easier to manipulate the transform, which makes try to make it as easy as possible, even though we can't modify it. In the code, you might actually see me use these private properties, but I only use it as a read only because I don't want to waste my time doing a function call to use a get. So in that instance, if you really want to just take away that one function call, you can access these directly, but you should only use them as read only, as a constant. Never as a way to modify, because if you might modify these directly, is modified will never get set. So the local matrix won't be updated for you. You'll notice that things aren't moving, things aren't rotating, things aren't scaling. So yeah, so I just a couple of extra functions here and there to really kind of just help you out. Scale is probably the least thing you do. Um, Another big change, and one big change is really that the parent-child relationship got fixed up a little bit. Um, it modifies itself a little bit more, and it actually notifies its children when it's been updated. So it makes it a lot easier to kind of get to kind of handle the parent-child matrices, because it's this way I can get the worldview a lot easier and when I'm doing things. So there's a new one in here called a parent modify. So every time the parent updates its world matrix, it notifies the children that, hey, my world matrix has changed. Next time you guys do a matrix update, even though you guys didn't change locally, you need to update your world matrix based on my world matrix. So that little extra was added to parenting to kind of make it easier to where I can just modify the parent and all the children automatically know to next time they do an update, they need to update their matrices. Because before the renderer, I would have to break out the parent-child relationship and then make sure I render parent-child in the right order. And by doing this, I don't need to, because the parent automatically kind of notifies and everyone kind of handles it. And we're going to build new layers down the line. So that's one of the big changes of fungi. So because it really changes your code if you're going to use this for anything. Like I said, because this is now private, and you have to use these functions that kind of modify it. Another big change is the rendering. The renderer took a big modification. Because I got to the point where I start making a lot of exceptions, and there's a lot of exceptions, and there's a lot of duplication, and the renderable. This is extends transform, and this used to have a draw function. I don't have a draw function anymore, because since I had a year worth of examples of what I want to do when it comes to rendering, I was able to kind of put all that together into the renderer. And like instancing was always something I had to do as a side step. The renderer now handles instancing itself. It handles just about everything nowadays. That's why I don't need the draw function anymore. But the draw function still can be there. It's still there as an option. Like right here, when it draws scene, if the draw function exists, then you run it. The only instance that I need to do a draw function is for the particle system, because a particle system is a very complicated manner. Like if you took the videos about how I was building a particle system, has transform feedback. It's dynamically creating these shaders to actually basically create these shaders that are used as compute shaders. So when it comes to the particle system, I didn't want to build that draw functionality into the renderer. So that's why I made draw as an option. It's kind of like an override. To make it as an override, I decided to break out all the rendering pieces into little functions, like load material, load shader, load renderer, draw renderable, So this way, when I draw, I can pass you the renderer, and then you can use all this functionality to kind of make rendering a lot easier and a lot quicker, and a lot easier. So if you want to do a custom draw function, you can still use renderer, and on top of that, it helps. Like if you do if you have a bunch of objects that are have a custom raw renderer, and you usually like functions like load material. Load material checks to see which material is currently active, which one is shaded. So this way, we're not switching shaders and materials when we don't need to. The old renderer did that. That was automatic. Right now, like I said, it's still automatic when you kind of just render it normally. But now that it's broken down into pieces, you can then access those pieces. So this way, you don't write the draw code anymore. You don't really need to. You use the renderer to actually manage all that data for you, and you can only you can just change the order of, like, sometimes I need to set up like 3 or 4 different shaders, and I just want to swap them back and forth. I can then just say load shader. Here's a shader, load it up, get it ready. So this way, when I'm done using a custom draw, and then I'm going to start going back to a traditional, like just a regular draw. All the settings, like which frame buffer is currently active, which material is currently active, which shader is currently active, I know it. So this way, if just in the case that's the exact same shader or exact same material, I'm just drawing it for some reason differently, I don't need to switch it. So that's one big change for renderer. It's more modular. I built it as a more modular, reusable thing. Yeah. And right now, scene is also a new object. Scene originally was just an array, and reason why I built it as an object now, and we have a new function called add, is because we're going to build our scene, and before we render it, we're going to build our rendering list. And the rendering list will then take apart the parent-child relationship and then put them in new order. And on top of that, I want to build other pieces like rendering order. So maybe I want things to render first and I want things to render last. So this way, when I break everything apart into individual rendering items, I can do that. I can actually I can then set up order of rendering. So scene is right now is kind of very simple, but in the future it's going to have a lot more functionality. And once I break the entire scene apart into little individual items that we're going to be rendering, I can do sorting too, because I want to do frustum culling, and that helps. You know, this way I have the entire scene. I don't have to worry about parent-child relationship. Everything's a nice flat array. You know, things like that. So, and on top of that, once I have everything built like that, I can do a bunch of other filtering. I want to build an update system, so where your renderer can have an update function, and I can just quickly go through the flat list and find every function that has an update. Just call it. So I have a so the rendering pipeline can be extended down the road, because right now we do all our code on render function, and that's perfectly fine. But if we were to start building a system like an actual game, we might want to have little update scripts, kind of like how Unity does it, inside our little rendering objects. So I'm laying down the framework for the future. That's why I'm kind of one of the big pieces of reason why I kind of redid Fungi, because it wasn't ready for some of the future things I really want to do for the next level. Where for the past year, Fungi has been developed, in my mind, really as a 3D rendering engine. That's all I was really kind of focused on. I did a lot of little gamey things here and there because I wanted to have fun. But primarily, this whole year and a half has been focused on just getting to the point that we can render just about anything. That's why we had the beginnings of the voxel system, right? The beginnings of the particle system. I just wanted to get, how do I render that? How do I do the 3D graphics of that? And that's why it allowed me to build this renderer the second time around, because now I've sampled all these little pieces that I want to explore, and that's where we're kind of at this point now in this series. It's like now we're at the point of the series that we kind of got just about everything we need done for rendering. Well, there's more things we can do, like I said, like culling and other things that we can still add to the renderer. But when it comes down to just here's something, render it on the screen, we got that done. Everything related to that's done. We got a little bit of armature working. We got the animation working. We got that system partly working. So like I said, we got a little bit of everything working that we need for a game. But the main focus has always been, can we get 3D rendering done in all these different types of systems? So Fungi is now ready for the next step. And the next step now is let's focus on how do we render things. And now the next focus in the series is really, let's start rendering things. Let's start building things. Let's start building worlds. Start building characters that move around and jump and fly. Like let's actually start building mini games. You know, build some basic mechanics of games, things like that. Not just constantly just dealing with rendering things. So yeah. So so the math library is pure. Rendering has been redone. How downloading and uploading has changed a little bit. Originally it was the downloader loaded things. Now it's kind of two different things. You have a downloader which only handles downloading, and then inside data we have a loader which then handles loading. So it's two separate things. Everything, like I said, everything got restructured. To me, everything makes more sense. Um, let's before I talk about the structure. Let's see. One big change is the camera. The original camera was more complicated, and I was I call it the orbit camera, and the orbit camera um, did things in a custom way to provide the orbit, and most people did. I guess no one really realized except for me that specific orbit camera, even though it worked pretty well, using it as the default camera caused issues, especially when it came to the normal matrices that I need to generate. So the camera has been kind of rewritten as basically a very basic fundamental camera. It has no crazy functionality to do orbiting or anything. It's just an extension of transform. It just handles the matrices that need to be done, and a projection matrix, which would be either perspective or orthographic, and that's it. It's a very basic camera. This way, I can make this into a third-person camera, which actually it kind of is right now. I'll show you a little later. The camera, because now we have the input, which is our regular controller, but now all the functionality is in the controller. So our main controller is almost practically the same, but now we have the new camera controller, which has been completely redone. And it's now primarily a first-person camera. It's a first-person camera, and it does have orbiting capability. So this way, we instead of just constantly stuck in the center of our world, which we've kind of been doing for the past year, like I said, the next step is that we want to start exploring our world, start building and exploring them. So that's another key aspect that needed to change was the camera. The camera had to be simple enough where we can reprogram it and move it around and do whatever we want with it instead of being kind of very focused on just being an orbit camera. Like I said, the transformation matrices that it was creating wasn't the correct order of operations, which were causing issues for me to rotate the normals. So when I want to do lighting, so now that the camera is back to normal, we don't have to transpose and do these other crazy things in our shaders anymore, which actually simplifies things a lot better. So the camera, like I said, is another big thing that kind of changed. Another big, to me, change is before I used to have boatloads of shaders. There's tons of shaders in here. In the fungi folder, in the shaders folder, in the fungi folder, is only going to have the bare necessity shaders that are important for basic rendering. So like I have a basic color, low poly fong lighting, which auto-generates the normals, so you don't have to apply normals. So sometimes I have objects that just don't have normals. So this way, this shader allows me to render objects with no normals with lighting. You got a shader just to handle textures, and there's the custom shader that I use for the debugging. For a lot of my debugging functionality is in here. And speaking of debugging, I don't have debug line and debug points anymore. I decided to just get rid of that, and they are now considered primitives. And debug line and debug, originally I had something called visual debugger. Now I have just these primitives called lines and points and line boxes. So I just make an instance of these and then just use them as if I was using for debugging. So I can just say add point, add or add line, or add box. And those are basically my debugging tools, but I don't have them set up as debugging tools anymore. They're kind of just set up as just simple primitives that I can reuse, that I can just keep creating. So basically it's one element, the one rendering object that has a bunch of things. Like when it comes to line boxes, we use that to help debug what's it called now? Voxels. So I can create a bunch of voxels, and it's a single draw called to draw all those like what do you call? Oh my god! I know they're boxes, but they're like skeleton boxes. They're just boxes made out of lines, really. So yeah, everything's kind of bare bones, primitives. We don't have a bunch of things anymore. And the last big thing that I say has to come with the changes of fungi is folder structure. The folder structure has been changed. When I do these lessons, like I said, the thing that's got really messy is that I would actually have to copy the entire fungi folder. That includes everything. That means that came with the particle system. They came with a bunch of shaders that I only used once for like one lesson. It came with voxels. Like if I'm making a video primarily on just like a simple concept and I just want to use a cube, I don't need all these systems in the folder. It's kind of just wastes GitHub space and stuff like that. And it's a bunch of code that's not needed to be there, doesn't need to be loaded in or anything like that. It's kind of just a big waste. So everything in the fungi folder is essentially the bare minimum to render. Is just the rendering 3D graphics engine. That's all it does. It does not handle anything related to anything else. It just handles graphics. So when I create these lessons, all I have to do is drop that fungi folder and I'm good. Now all our systems have been broken out into a folder called fungi mod. So we have armature system, our particles, post effects, ray casting, and voxels. All our systems, they're just data, essentially. That's all. There's just ways of managing a bunch of data that then get funneled into fungi as rendering. So if I make a video on just armatures, I'll copy the fungi folder and the fungi mod armature folder, and that's it. Particles, ray casting, all this stuff wouldn't be there. There's no need for it. There's absolutely no need for it. So it just makes the lesson library a lot leaner. And then we got a lib folder. And the lib folder is just kind of like these random things I create or I find online. Like we have the GLTF loader I created. I have a Canvas 2D. I'm doing a lot of 2D stuff now. I have the noise library that comes from this site. I think I just rewrote this as a ES6 module, so I can load this in a lot easier. I have this tween object. I think all the functionality came from here, but I rewrote it, the tween, so it's easier for me to use in fungi. So like I said, it's just these extra bits of library code that I write, and I have like a new overlay thing, which is a new cool little system that can be really useful. It's just a way to create UI on top of our rendering, so we can actually start controlling things. So we can start doing some really fun stuff, and I'll show you like a quick example of it. And I text notes and things in here now. Like I'm learning how to do derivatives now, and I've done some code dealing with derivatives. So I have like notes in here that people might find interesting, ideas I want to try out, so you can kind of get an idea of where I want to go. Really fun stuff, vector fields, voxels. I want to deal with physics, shaders, and terrains, and morphing meshes, and triplanar shaders. There's a boatload of things I want to do, and when I find information, I'm starting building this huge file. So when I want to sit down and think about, okay, what do I want to do? I can look right here and say, all right, this is the next thing I'm going to work on, because I want to do this next. And I have like miscellaneous notes too, like bits of code I find online. There's fog. An example how to do fog, which I might want to end up doing in the future. So in the GitHub, you'll actually start seeing where I am mentally when it comes to fungi, like where I'm going, what things I'm thinking about. If you're not following Twitter, this is like a really good way to really see where I'm going, where fungi is going, because I'm just going to update it with information to help me out. And the last thing about the folder structure is I have a files folder that has everything. And I have the experiment folder now that I do write experiments. That's where our web server is that I built using Golang that we can use to actually execute our site or our code. And I have a new folder called examples, which gives you like examples of how to use fungi to do different things. And I built fungi as a way that you can kind of actually load up the graphics engine without actually using the entire graphics engine. That's why I have a folder called raw, and like here's an example of how to load fungi bare bones with nothing, no rendering engine, no rendering loops, no nothing. It just this is like basically the bare minimum of what you need. create a shader, create some kind of object for rendering, make a VAO out of it, and then just do a draw call on it. And this is not even using the rendering object because it just draw this VAO. So the VAO object has a draw function in there, so you can just draw VAOs directly if you need to. Like I said, the whole rendering engine, the whole Fungi has been broken down into pieces, so you don't really need to use all the pieces. You can actually use bits and pieces. You can just use the graphics engine any way you want. And this example folder kind of shows you a lot of different things you can do that you don't have to run the full Fungi engine, essentially. Yeah, this one, how to use the render in just render without a render loop. So if you just want to do one model and just render it, that's it. And it just all it has an init. It loads a local shader. So like I said, there's a bunch of cool raw examples, and then there's more advanced examples of how to use the engine. And so yeah, like inside the examples, like when I use these examples are now what I would consider my test files. If I do any big changes to Fungi, these are going to be my test files to make sure the engine's still running. Like the graphics are still working, everything is in good shape. So we got basically got all the greatest hits when it comes to Fungi for the past year of videos. We got the GLTL for loading and animating. So this loads up a GTLF file and takes the animations and animates it. You know, it's working in the Fungi. I don't know, you want to call it 2.0, whatever. The greatest hits of like building armature, like literally from scratch, like absolutely from scratch. In case you haven't done that video, the armature raw file is awesome because there's no mesh to load. You actually build the mesh yourself. You build the skeleton yourself. You apply the joints to the vertices. And then you have how to just manipulate the joints and the shader code that goes along with it to actually make armature. Like this is like a bare bones from scratch, no tools whatsoever, completely procedurally generated skeleton and mesh. So it's like I said, it's like these examples are really cool. Like if you really want to come in and just want to quickly learn a bunch of cool things that's kind of hard to find online. Like this is like you don't find like examples like this online. Like seriously, you usually load in an object and it has all the bones into it. This is kind of fun. Like if you really want to experiment with building things from scratch, like really understand the core mechanics of game development, you know, because like if you can do things like this, loading in a mesh and then loading in a skeleton and then just running it through the armature is very easy. Building this stuff from scratch, that's the challenge, man. If you can do this, if you can understand and do this on your own, you can do it. You know, it's like to me, it's like that's like a good example. Like to me, I have an issue where I think I'm never good enough, and you just have to think that. Like I just have to remind myself. Like look at this example. I'm doing something that you don't see very often, and if I can do it, that means I can do it. You know, it means there's I have to tell myself that I am smart enough to do it. I'm not a mathematician that can build everything and understand all the mathematical rules around it, but I can understand enough of it to do something. You know, to get an idea of how it all works behind the scenes. You know, it's that whole premise of this series is that you don't want to be the guy who uses Unity. You want to be the guy that can build Unity, and that's one great example of, hey, you can do that. That means you're a Unity builder, not a Unity user. So, yeah. So that's that to me. That's what Fungi has always been. It's just how far can we go into learning before we hit this brick wall, or we just can't go any further because we're just not smart enough. Like, or I should not me. Am I just not smart enough to really get to that point? And so far, we've gone pretty good. You know, like I feel like we've gone pretty good. We got the greatest hits of raycasting. You know, we got. And there we go. I can shoot the rays over here too. and they hit nothing. So like I said, we got all the greatest hits. You know, red is coming in and green's going out. We got voxels. We got our voxel fun. Basic voxel, very simple. We got our sample of using voxels ray casting. Look at that. Like I said, I had a video of how we built all this. Even though this is using new fungi, it's really all the same things. It's just the code has been cleaned up, has been rewritten to be a little bit more optimized. So it's a lot, you know, if this is kind of a great supplement if you want to come back and say, well, you've done those videos, like, hey, let's look what the current code really looks like now. Like it's been cleaned up and fixed up, and maybe more comments have been added to really learn. And that's one big focus when it comes to this series, me in general. Lots of comments. I try to write as much comments as possible because I want the idea that if you come and look at my code and you'll come here with the idea of learning, that even without the videos, that maybe you can learn how these things work. Maybe the videos I might be going into more detail how these things work. That might, you know, it's all good. I love this example. This is one using the a very efficient ray casting for voxels. It's a very efficient way to traverse voxel data. I love this example because it took me a long time to really get the coding just right, because I had a hard time understanding it. It's like one of those, like I said, another good example of never thought I was smart enough, and I managed to achieve it. You know, perseverance, I guess. You know, and particles. You know, we got our basic particle system. And oh yeah, I wanted to show you the camera. So let me go back to voxels and raw voxels. So we, like I said, we still have the orbit. I have to hold down the control button to do orbiting. If I don't use the control button and just mouse, I actually do. Look, it's a third. Like I said, this is actually a third-person camera. So if I click and hold, I'm actually doing a first-person look. So I can look up, look down. I can use a scroll wheel to move forward and back, and I also have keyboard controls, so I can just reorient myself, and now I can start traversing the space. And I can rotate, go to that corner. I can just hold forward and kind of just drag myself around. And this is something we couldn't do before. Like I said, because the orbit camera kept us stuck in one place of the world. And I can do panning. So I just hold down the shift button and I can pan up and down, left and right in our world. And again, I can use the keyboard to kind of help me traverse through. I have this button for rotation. Rotating is a little funky. I'm not too happy about how rotation works when it comes to the keyboard camera. But overall, everything works pretty well. And like I said, if I hold down the control key, everything kind of springs back into the orbit camera. So like I said, this camera is awesome because I like the idea that once I start dealing with one of the things I want to do soon is voxel mazes. Just use our voxel code and just use a maze algorithm and just build like a voxel maze really quickly. And then this camera will be great because I can just probably traverse it. Maybe I'll build like a little bit of gravity, so this way I'm stuck to the ground and I can actually walk around with the voxel maze. So that may be something that's I want to do in the future, because that'd be fun to do. Because like I said, it'll help us start building worlds, like building mazes and using voxels and terrains and whatnot. And like I said, raw folder has just very basic stuff, like bare bones. This is all you get with bare bones. Just you render to the entire screen. Textures, just how to render a texture. How to use UBOs, UBO raw. I like the UBO raw one because it has tons of information that pops up, so you can see how all the information, and it helps me debug if I want to build UBOs. Like I have like this memory visualization of what the UBO looks like when it comes down to binary. So like I said, there's a lot of cool things in here. Like I said, everything in the example folder is really basically my test. I actually, there was actually a piece that's a little broken. I actually fixed it today before I started recording the video. It's like, oh man, armatures are broken. And then I just realized, because I did a big change to fungi at a core, that I didn't fix the armatures to take into account that one change. And basically, that one change is that in the previous renditions of fungi, in the render loop, we used milliseconds as time. I changed it so we're dealing now with only seconds, because seconds is better, like we're just fractions of seconds, which is milliseconds. But the milliseconds was in whole numbers, so it would be like an integer of like 1,000 or 900, 500, and every time we wanted to use it, we had to kind of divide by 1,000 to kind of bring it down. So that kind of was like a waste of time. So I decided to just shift everything into seconds instead of milliseconds, so it's already at that fraction. So this way, we can then easier do animation. So if I want to say I want to move 10 units per second, I just pass in delta time, which it will be in just a fraction of a second instead of being like in milliseconds whole number, things like that. And since time, I think, or since started is another one. I forget. So yeah, files. It's in fungi. And the main fungi file has just basically all the thing. Another big thing I changed, I did a better job of handling our resources. So I have like our resources, like containers, and then functions of how to grab resources dynamically. Because like I've been doing more things where I'm pulling and grabbing materials randomly and things like that, and tweaking them. So yeah, it's since start and delta time. So this data now exists more as a float value, as instead of like whole integers based on milliseconds. So it's really, you can use the fractions a lot better when it comes to animation. So like I said, there's a lot of small improvements that breaks things that I had to go back and fix. And the math library is, cleaned up quite a bit. But it has all the greatest things. I have like this here now. This is great. To use, so I don't have to recalculate them again, because I tend to calculate pi half and pi 2 so many times. It's just nice just to be able to load this math library. I have the main things I need: vectory, matrices, and quaternions, and some of the constants that I need a lot. So it really helps. And there's other bits in here that are kind of still hidden that I don't know what to do with, but yeah. But everything else that we've done for the past year is here. Everything is good. Everything's working. So I'm really hoping that moving forward, we're going to be doing a lot of cool things. I think the last thing I want to show you is the UI. The UI will be inside one of our experiments, and do something. Sure, why not? I'm going to use one of these. So this is one of my experiments, and this is what this file is. If you go into libs and you see overlay, which has a style sheet and a JS file, this is what overlay is. This modifiers. This way I can do control for it. Like right now I'm using the 2D stuff, but I'm going to be able to start using these to control visually 3D things. So it's kind of just this HTML element that exists on top of the canvas. But it allows me to create these little simple controls for, stuff to control things. So it's not more fun. So if you want, I'll just quickly show you an example of what the API looks like. I made the API as friendly as possible, for me anyway. I consider friendly. I think that was 3. So that's it. It's like I just load in the overlay. It kind of actually loads in the CSS dynamically itself, so I don't have to actually put it into the HTML page. And it's that simple. I just initialize it. Title creates these titles right here, and then just say range. Give it a title, give it the range, and give it a function of what to do when there's a change. And I've seen other UIs that are like this, but they keep the information internally, and I don't want to do that, because when I do a lot of prototyping, I have things existing as a global scope anyway. So to me, it's just easier. Just pass in like a function pointer, or just a custom function that just updates these global variables for me. So this way I can then very easily, simply create these control tools or these controllers to control things. So yeah, that's another big piece that we're going to start seeing more in the future in the videos. These little control things, so we can do, like I said, like I'm just controlling how these animations works, without actually having to change the code, go back, reload. We can just build all the functionality right here, and then voila, we can kind of see. And as you can see, I'm dabbling more with 2D. You might see me do show off more 2D things in the future to show concepts of it. So this, and then a lot of times the 2D can then translation into 3D because the code for 2D is a lot simpler most often because you're only dealing with vec2s and things like that. And it's flat, so I don't have to deal with orbiting and running around. So it's a lot easier. So this can be converted into 3D. So yeah, like I said, in an experience folder, there's tons of things you can look at. The experience folder will always break or unbreak. I'm experimenting with a lot of things. These are from wacky things. Like I said, I want to deal with physics in the future, things like that. So let me just load something in. Like I said, this is the best. So pretty much near the end. So that is the recap of everything that has changed in Fungi. So if you've been following me for the past year and a half and been building up Fungi, your own version of Fungi, or you just copy whatever I do, big changes. I'm sorry if I kind of just did it without you guys. It's just there's so many changes that I just couldn't follow with you guys to do it. So, but like I said, there's everything we've done up till this point is still there. It's just everything's just been refactored and optimized and just kind of fixed for future code. So that's why I wanted this video for those who have been following and building their own game engine with me. And this is what I wanted, just to show you guys the recap of everything that's changed and some of the reasons why I did it. Like I said, we're going to do some more advanced stuff in the future because we're kind of done with phase 1. We're done rendering. Now let's start building things. Like I said, I want to build that maze. The next video is going to be about building a planet. It's going to be a simple planet. It's nothing level of detail type of thing. It's going to be very simple. Really more dealing with shaders and textures, doing more advanced things with textures and things like that. But that's the next video I'm going to record today. I'm going to record like 3 videos today, maybe more. So there's Fungi. Now, what is Fungi? Which is probably something I should say at the beginning, but to me, it probably makes more sense at the end if you really care about Fungi. Fungi, for me, like it's a learning tool. To me, it's not a production ready thing. To me, it's an educational tool. Everything is in flux. Everything can change. Like I said, I just pulled a rug over your eye, right from under you, because I kind of rebuilt the whole framework. A lot of code you might have might not work anymore, especially because of transform. Transform has a big fundamental change, and you can't modify the properties directly. You have to use these new intermediate functions. And the renderer changed, and the draw functions has gone from renderables and things like that. So, sorry for anyone's following along, and I kind of just pulled that rug from you guys, but it's kind of important for me to continue on, and there's just so much to change. Like I can't create videos of every little thing I'm doing that took me a year and a half to build. So I'm sorry if this bugs you or anything, but the source code is now available, and it's available in its own library right now. It's Sketchpunk Fungi, and like how I said, it's a rendering engine and a game engine. But like I said, Fungi to me, the main focus is really just a rendering engine. It's really how do we render things. How do we get things rendered on the web using WebGL 2.0? And like I just said before, it's a learning tool. It's always in flux. It's not production ready code. There's sort of small bugs here and there and whatnot. And like I said, in a year from now, I might refactor yet again because things can change. Like there's still so much to build that in the future, how I have it now makes no sense anymore. It needs to be redone to for maybe the next phase, which I have no clue, which is actually full-blown application instead of doing, like I said, I don't know what's going to be from a year from now. But I've been doing this for over a year and a half now, and I don't see myself stopping because I love this. This is awesome. This is amazing. I love it. I've gone further than this that I ever thought I was capable of. Like I've gone so far beyond this that I have not realized that I was going to make it this far or really stick to it for this long. I've done so many things in the past that I kind of just do it for a couple months and then I stop. It kind of really shows you how much I love this. So this is so important to me that I'm sticking to this, and I'm taking to the very end. And if people are wondering, like, am I really focused to becoming a game developer? Hell no. I'm going to tell you something right off the bat. I will never ever be a professional game developer. Because I can't deal with long hours. I can't do 80 hours a week. I cannot work for a game studio. Now, what I can become is an indie game developer, where I run the rules. I do whatever I want. I don't have to tell people what to do, or people tell me what to do or what to make. If I don't like a project, I just drop it, and I don't have to worry about it. I'll just move on to something else. So, Fungi might become my personal future game engine that I use for my own personal fun stuff that I want to make. Like I said, I want to do desktop stuff too. So eventually Fungi will be created in desktop using C++. But Fungi on the web will always be the starting point. It will be where I prototype. This is where I learn how to do things. And then, like I said, can you imagine me have to rewrite this in C++? It would drive me nuts. It's easier to rebuild everything and make mistakes in JavaScript. So that's why I kind of say this is a learning tool for me. It's going to be a learning tool for you as well. And please don't take this as a replacement for 3.js or for A-Frame or any of the existing frameworks that exist, because those are being worked on for production use. This is not. So like I said, this is a learning tool. That's what Fungi is. It's a learning tool. It's something to kind of learn how to build a game engine. And it's building a game engine that with a lot of mistakes. 3.js is really not a game engine, but it can be used as one. But it's so complicated. It tries to be something for everyone. And that's kind of why I don't even want to use 3.js, because it's just too much. And I don't like how it's built anyway, for me personally. It's just too much. And that's why I kind of built Fungi in an abstract way, where I build everything in pieces, and then I kind of abstract it. And I have like these files that show me how to do it the hard way, and then I have the samples of how do I do it with the abstract way. I don't know if 3.js has things like that, but I know their code is very complicated. I've seen some of their code is just way too complicated sometimes. Like the way you have to build everything, it just, to me, it feels like too much work. If I have to actually code my game and not have like a tool like Unity to help me lay it out, I will make the API as simple, as basic, and as Pedro friendly as possible to make my life easier. And I have no experience with A-Frame, so I don't know. I can't talk to that. But like I said, there's a lot of frameworks out there. Just A-Frame and 3.js is like the main ones out there when it comes to web. So that's what Fungi is. It's not production ready. I don't build this to work on everything. I focus everything to work on Chrome. This definitely does not work on Internet Explorer, so it won't run on Internet Explorer, because I think Internet Explorer doesn't even support WebGL 2.0. I don't even know if it supports even 1.0, but definitely doesn't support 2.0 last time I checked. So it won't even work on Fungi. And I don't think Internet Explorer or what's it called now? I don't know. It has Edge. I don't think it even supports ES6 modules yet. And this entire thing is built to ES modules. And I built it literally the day after support was finalized in Chrome. Like Fungi didn't work in Firefox for the longest until Firefox turned it on. I don't know, not too recent, but sometime after Chrome did. So like I said, I build this primarily for Chrome. It's a learning tool, and it's not meant as a production ready tool replacement. If you want to rewrite it to work on everything, go for it. Like I said, this is an open source project. You can do whatever you want with it. I have a license in there. I think it's an MIT license I picked. Like I said, I don't care. I'm telling you right now, I do not care what you do with this code. Go ahead, have fun with it. Because like I said, I might rewrite it in a year again. I don't care. So it's open source. Do whatever you want with it. Because it's built off information I found online. So the information I found online was free and open. So anything I built from that information should be free as well. It's just me passing it forward, I guess. I forget what the phrase was, like passing, I get something for free, so I give out something for free. So it's just passing that knowledge, just spreading that knowledge in just a more neat packaged way, I guess, especially with that example folder. So spend too much time. I got some real videos to record because I'm sure you guys want to learn some real stuff and not hear me babble on like a vlog. I'm not a vlog person, but I tend to use these videos like vlogs sometimes, don't I? At the very end. But like I said, this video is nothing but learning, so I can talk all I damn well please. I'm unemployed. I got tons of time. While I'm looking for work, I'm working on this and taking care of my family. So, yeah. So that's it. I'll see you guys in the next video, which I'm going to start recording hopefully in a couple of minutes. I hope you guys enjoy fungi.